are classified to natural numbers, whole numbers, integers, rational and irrational. Now let's start with the natural numbers. We're talking about counting numbers. Some discrete number. We can count them. 1, 2, 3, like number of cars. 1, 2, 3, 4, 5. So here we have 1, 2, 3, 4, and so on and so forth. 3 dots means all the way to positive infinity. Then we have whole number. Whole numbers means we have to add 0 plus natural number. So we have 0, 1, 2, 3, 4, so on and so forth. Okay? Integer, it's all whole numbers plus the opposite of natural numbers. So we have here from negative infinity, so we got negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. Okay, let me try to make it bigger here. And then we have rational. Now, a rational number is a number that can be expressed as a quotient, as ratio between A and B, right, of 2 integers. Now, A must be integer and B must be integer. Of course, A is called the numerator and B is the denominator, and B should be different than 0. Like if we have here A over B, okay, so A over B, now A is integer. Okay, let me change the color here. Now A is integer and B also is integer, okay? And of course B should be different than 0. Now let me give an example. Here we have, I have like 3 over 4. We got like minus 1. Now minus 1 could be written as minus 1 over 1, right? Here we have 0. 0 is rational because we can write 0 over 2, or 0 over 3, or 0 over 4. I think we get the idea here. So because 0 is integer and 2 is integer, right? We have one of the characteristics of a rational number, can be written as decimal as well, right? Or fraction, no fraction. And like for example, if we have like minus 2, let me just erase this. Let's suppose we have, let's suppose here we have minus 2 over 3, right? Now, minus 2 over 3 is rational. Now, if we divide like minus 2 over 3, we're going to see, this is going to be like equal to minus 0.666 all the way to infinity, right? Now, this, this number does not terminate or end, right? However, they do exhibit a pattern of repetition, which is 6, the same number. So the same number repeating itself. Now, we can write this as this, like we can write this like 0.6 here, and we put this sign here. That shows me that the same number repeating itself does not terminate or end, but they do exhibit a pattern of repetition. It's the same thing, okay? Now, unlike if we have like 5 over 2 is 2.5, that's also rational, right? So we're going to see an irrational, which is going to be different, where the numbers are not terminating, but it doesn't exhibit a pattern of repetition, and it's getting all the way different, right? For example, for irrational number, when we talk about, let's talk about square root of 2. Now, square root of 2, it's about 1.41, 42, 13, and so on. Now, it doesn't. The numbers do not terminate or end, but they're getting different here. We got 4, 1, 4, 2, 1, 1, 3. So these numbers, it shows me that we're talking about irrational number. Also, if we talk about pi, now if you see pi, it's equal. Well, pi equals to about 3.14, 15, 9. Now, not the same number repeating itself. So they do not exhibit a pattern of repetition here, okay? So this is called irrational. Also, if you have like square root of, well, if you have like square root of 2 over 3 and so on, it's the same thing, right? It's the same thing. So this is irrational. Again, for rational number, we're talking about number could terminate or could not. I mean, some numbers do not terminate, like 2 over 3 or 7 over 66. This is rational because they do exhibit a pattern of repetition, right? However, for irrational, unlike rational, for irrational, we got different story here. We have square root of 2 is equal 1.4142. Now, the numbers are not terminating, but they do not exhibit a pattern of repetition, so we have this case. Well, let's have an example. All right, we're going to move to, here we have, list the numbers in the set. We got negative 3, 4 over 3, 0.12, square root of 2 pi, 2.15, 10. So A, we need to have natural numbers, and the natural number is only 10. It's only 10 here, so it's going to be 10. 10 is natural number. For B, integers. Now integers is its whole number plus the opposite of natural number. So all negative numbers, 0 plus positive numbers. So we get minus 3 here is integer. We get 10 as well. Okay? Now, let's move to C, rational number. Again, rational numbers is a ratio of two integers, like m over n or a over b. So rational number is a number that can be expressed as a quotient or ratio of two integers. All right, so here we have, well, minus 3 can be written, minus 3 is rational because we can write minus 3 over 1. No, minus 3 is integer and 1 is integer, right? How about 4 over 3? Yes, it is integer. I'm sorry, it is rational. We got 0.12. Now again, 0.12, it terminates, right? 0.12, it terminates. We have, it terminates and also can be written as 12 over 10, over 100, I'm sorry. Okay? Here we have square root of 2. No, I'm sorry, we have 2.5. Now, if you see 2.5 here, if you see 2.5, 2.15, now 2.15, as you see, it's continue on, and it does not terminate here or end, but it do exhibit as a pattern of repetition. Here we have 2.15, so definitely 2.15 is rational. And then we have 10, of course, is rational. Okay. All right, so let's do irrational for D. Now, irrational, it's easy. We get square root of 2 and pi. All right, and I showed you before why it's irrational. It does not terminate, and it does not exhibit a pattern of repetition. And also we have renumber. Now, renumbers means all numbers, not all numbers in this set here. When we talk about all numbers, okay? So we mean this. We mean all these values in this set, okay? This is, here, here we have like a picture, like a good picture about, it summarizes what we've just done. So natural number, we're talking about 1, we're talking about 1, 2, 3, the counting number, we can count them, right? The whole number, we're talking about 0, 1, 2, 3, and 1, and so on, all right? And then integers, we're talking about negative numbers and the whole numbers and the opposite of natural numbers. We're talking about negative 3, negative 2, negative 1, 0, 1, 2, and so on, right? And rational numbers, it's any value, any ratio of A over B, this must be integer, okay? And B also must be integer. Of course, B should be different than 0. I think you get the idea here. Irrational numbers, we're talking about not terminating, not, and it doesn't, we don't have repetition of the same number, like square root of 2, like pi, or pi over 4, like e. Now, e is an exponential function, and it's about like 2.71, 82, 81, and so on. So the numbers are continue all the way to positive infinity, and are different numbers, values. So this is irrational. All right. Have a good day.